Hi everyone, welcome to Math World. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 6, which is a Probability and Statistics 2 for February-March 2023, and the code is 9709/62. Please subscribe to my channel if you enjoy watching my video, and I will upload more videos in the future. Alright, so thank you. Now let's start with the question number 1. Now, question number 1, Anita carried out a survey of 140 selected students at her college. She found that 49 of these students watched a TV program called Bunch. Now, A, find an approximate 98% confidence interval for proportion P of the students at Anita's college who watched Bunch. Alright, so now the solution is 98% confidence interval for P for proportion. The formula is going to be P hat plus minus Z square root of P hat Q hat over N. Okay, so for information, it's mentioned that 49 out of 140 watched the program. So that means a P hat is going to be 49 over 140. Okay, then this can be simplified into 7 over 20, and hence your Q hat in the formula over here, it is 1 minus P hat. That means it's 1 minus 7 over 20. Then you will be getting 13 over 20. Okay, so now from this formula, we need to get the Z value. So this Z value can be found using the normal table. So now firstly, I sketch the graph for normal graph. Okay, then I have to look at the 98% confidence interval, means that the middle is 98%, which means it's 0.98. Okay, we know that the total area under the curve is 1, which means this region on the left hand side is going to be 1 minus 0.98, which is 0.02, and divided by 2 because we have left and right side, so which is 0.01 here. Okay, which means now when you refer to the normal table, we need to get the total region of the green arrow. So obviously it is 0.98 plus 0.01, then I will be getting 0.99. So this is going to be 0.99. And now this 0.99 can be the critical value of the Z when the probability is 0.99 can be obtained from the normal table in the formula list. Then you'll be getting 2.326. Okay, and this will be negative. Alright, so now I will replace all the values. This is going to be 7 over 20 plus minus 2.326, then square root 7 over 20, which is our P hat. Then the Q hat is going to be 13 over 20. Then our N is going to be 140. Okay, so this confidence interval has lower and upper limit. So the lower limit is counted using the minus, right? This minus sign. So when you count the value, it should be 0.256 correct to 3 significant figures. And when it is plus, to get the upper limit, then you will get 0.444. Okay, so now we are constructing the interval for proportion. Therefore, the answer must be between 0 and 1. Okay, so I have done the question 1A. So let's move on to question 1B. Now, Carlos says that the confidence interval found in A is not useful because it is too wide. B, without calculation, explain briefly how Carlos can use the results of Anita's survey to find a narrower confidence interval for P. So if you need to get a narrower confidence interval for P, just now was 98%. Okay, this is 98%. So if you need to get a narrower confidence interval, maybe we can just reduce the confidence level, right? That is one of the ways to do it. Okay, so I will just write use a lower confidence interval or confidence confidence level. Okay, so that is the solution of this question. Right, so next question is number 2. The number of orders arriving at a shop during an 8-hour working day is modeled by random variable x with distribution Poisson 25.2. Now A state two assumptions that are required for Poisson model to be valid in this context. Okay, so for Poisson model we know that it must be randomly. Okay, so the orders must be random, and then the orders must be independent as well. Okay, so it's mentioned that your X is number of orders arriving. So from here I will write number 1, orders are random, or orders arrive randomly. Okay, that is the first condition for the Poisson distribution, and then the second will be the independent. So I will write orders arrive independently, or you can say that it will be arrive at a constant rate. Okay, constant mean rate. Alright, so the third one, probably the third one, you can write orders arrive at constant mean rate. So I give you 3 assumptions here. Okay, basically these are the 3 conditions for the Poisson distribution. Okay, now B, first part, find the probability that the number of orders, means the X, that arrive in a randomly chosen 3-hour period is between 3 and 5 inclusive. Okay, so when you look at the question here, this 25.2 is for 8 hours. Alright, so now we need to get 3 hours. Therefore, I need to count what is the mean, right, over for the 3 hours. So this 25.2 is for 8 hours, therefore per hour I have to divide by 8 first, after that I multiply by 3. That will be for 3 hours. So I will get 9.45. Okay, so for 3 hours I will expect 9.45 orders arrive. And then now I let Y be PO, Poisson 9.45. Because this Y is referring to 3-hour period. So now you need to count probability that the Y is between 3 and 5 inclusive. So P 3 less equals to Y less equals to 5. Then from here, I will just use the formula. It will be Py equals to 3. I will list down the Y values first. Then Py equals to 4 plus Py equals to 5. Okay, so for your information, for the Poisson distribution, let's say X is PO lambda. So your probability of small x equals to E minus lambda to the power of x over x factorial. So that is my Poisson formula. Alright, so from here, and you should understand that the E minus lambda is a constant. Our variable is the x, which means now I can factorize the E lambda for all these 3 probabilities. So I will get E negative 9.45, then 9.45 to the power of 3, because Y equals to 3, over 3 factorial, plus 9.45 to the power of 4 over 4 factorial, plus 9.45 to the power of 5 over 5 factorial. Okay, so from here, when you calculate all of this, I will be getting 0.0866. So that's the solution of this question. Now part 2, find the probability that in 2 randomly chosen 1-hour periods, exactly 1 order will arrive in one of the 1-hour periods, and at least 2 orders will arrive in another 1-hour period. Okay, so now I have to find what is the mean number of orders arriving in 1 hour. So for 1 hour, basically it is just this, alright, 25.2 divided by 8. That is for 1 hour. So now I need to count what is the value for that. So 25.2 divided by 8, basically you are getting 3.15. So it means that per hour I will expect 3.15 orders arrive. Okay, so now it's mentioned that exactly 1 in 1 hour. So let's say the T now, T is Poisson, T means per hour, okay? The number of items or number of orders arrive per hour. So the T is Poisson 3.15, and then now exactly 1 in one of the 1 hour periods. Now P equals to 1 order, and then at least 2 orders arrive in another 1 hour period. So at least 2 order means that it will be PT greater or equals to 2. Okay, now for your information, it doesn't mention that the first hour, see, this 1 hour, one order is just arrived in one of the 1 hour periods. So means that now it's like this. This is 1 hour, the first hour. This is another 1 hour. So I'm not sure whether the first one is t equals to 1 or the second one is t equals to 1. That means for this, I need to multiply by 2 because it can be first hour or second hour for t equals to 1. So probably I will just write probability equals to 2 times, okay, because of the sequence there. So here again times. So now I will get 2 times, put a bracket. So again, this is the Poisson. Alright, so just now I have shown you PO, let's say lambda, Px equals to x is E minus lambda x over x factorial. Okay, so now I will factorize the E, negative 3.5. Alright, or I can just write down first, I don't want to factorize. Okay, then, because it's only one term, t equals to 1. So when t equals to 1 means that I will get 3.15 to the power 1 over 1 factorial. So I will just leave it in this form. And then for pt greater or equals to 2. Okay, this is going to be 1 minus pt equals to 0, then minus pt equals to 1. Alright, so here I will write 2e negative 3.15 times 3.15, then 1 minus, when pt equals to 0 and 1, I know that the common is the exponential. So here, you can basically factorize the minus and make it to plus here, inside the bracket. So I will write e negative 3.15. Okay, then when t equals to 0, now look at the formula here. Any value to degree 0 is 1. Then 0 factorial is 1. Okay, 0 factorial is 1. That means the probability of t equals to 0 after I factorize the exponential left 1. Then plus pt equals to 1 means that you will have 3.15 degree 1 over 1 factorial. So this is going to be my working. Now when you calculate the value, it will be 2 times. This exponential times 3.15 is going to be 0.134984. I give more decimal places because this is the working. And for the second bracket, it's going to be 0.822164. So when you multiply all three numbers and round up to 3 significant figures, you will get 0.222. Okay, so that's the solution for part 2. Now see, the shop only can deal with a maximum of 120 orders during any 36-hour period. Use a suitable approximating distribution to find the probability that in a randomly chosen 36-hour, see here 36-hour, there will be too many orders for the shop to deal with. Okay, so now when n equals to 120, okay, so from here we know that the n is large, right? So now I need to count what is my lambda first. So my lambda per hour, it will be 25.2 divided by 8, then times, now I'm considering 36 hours. So this 22.5 over 8 is basically for 1 hour. So now you times 36 hours or 36, that will be the mean number of orders arriving during the 36 hours. So I will get 113.4. Now, since this value is greater than 15, then we are using the approximation distribution. So that will be the normal approximation, which means my x initially Poisson with 113.4 orders arriving. Then now I will approximate it to normal. Okay, so for normal, the mean is same as 113.4, sorry. This lambda, right, for your information, for Poisson distribution, mean and variance will be the same. So therefore, when I convert it to, approximate it to normal, my mean and variance will be the same value. Alright, so now it's mentioned that it is too many orders for the shop. Maximum is 120. So too many orders means that it will be exceeding 120. Alright, so then from here, you have to, because your x is Poisson, which is discrete random variable, and then the normal is continuous. That means now I need to consider the continuity correction, which means here is 120. So when greater than 120, it will be 121. Okay, basically start with 121 and so on. So all these are the x values. Now when you refer to the continuity correction, the continuity correction, you are allowed to plus or minus 0.5 from 120. So it means that now I have two choices, either 120.5 or 199.5. Okay, since this is greater than, means that I have to accept the greater than 120.5. Okay, to include the two ticks. So here I will change to PW greater than 120.5. And then now I will standardize it. Then it will be Z more than 120.5 minus the mean is 113.4 over 113.4. Okay. Then now from here, you will simplify it into 0.667. So now when I refer to the normal graph, okay, 0, here is 0.667. The region is greater than. That means it's towards the right hand side. So obviously, the region, to get this region from the normal table, I have to use 1, which is the total properties, minus PZ less than 0.667. Because the value must be less than a positive number. The Z must be less than a positive number. So that you can get the probability from the normal table. Okay, so this is my step. And then now, when you refer to normal table, the probability is going to be 0.7477. And now from here, I will be getting 0.22523. And now round up to 3 significant figures, it will be 252. Okay, because after the 2, it is 3. It is not 5 and above. Okay, so I have done this question. Now, for the next question, which is the question number 3, the diagram shows the graph of probability density function f with or of the random variable x that takes values between x equals to 0 and x equals to 3. So that's why you see here 0 and 3. The graph is symmetrical at or about the line x equals to 1.5. This is the symmetrical line. Okay, so now it's given that px less than 0.6, which is here, is A. This is A. And x between 0.6 and 1.2 is B. So here is going to be B. Because when you consider probability, that is the area under the curve. Alright, so now find the x between 0.6 and 1.8. So from here, we know that the 1.5 is a symmetrical line, which means the difference here is 0.3. Okay, so the difference here, 0.3, is going to be 1.8. This is going to be 1.8. Okay, which means now you need to find the probability between 0.6 to 1.8. Okay, so from here, right, I need to get what is this first. Then it will be the double. Okay, because these two are symmetrical. The region here is same as the red, both red region will be the same. Okay, so from here I will have to calculate first. Now, you need to get 1.2 to 1.5 is how much? Okay, because you already given A and B, and then you need to get your answer for the red color, this red arrow, the longest red arrow in terms of A and B. So now I need to find what is my question mark over here, which means it's in between 1.2 and 1.5. So now, P x between 1.2 and 1.5. So now you should understand that since 1.5 is symmetrical line, which means the total here is going to be, the probability here is going to be 0.5. Okay, and now we know that the blue region is A, the green region is B, which means the red region is going to be 0.5 minus A and minus B. Okay, so from here I will write it is 0.5 minus A plus B. That is my x between, the probability of x between 1.2 and 1.5. And then it is also same as here. Right, the probability of 1.2 and 1.5 is the same as 1.5 to 1.8. So I will write here, this is same as P 1.5 and 1.8. So now, to get the probability of x between 0.6 and 1.8 is going to be, here is 0.6 to this, which is our b, then plus double of these two. Okay, so double of 1.2 to 1.5 means I double this value. So double of 0.5 minus a plus b. Okay, so from here, I will open the brackets. So b plus, this is going to be 1. Then these two multiply with negative together with the a, becomes minus 2a together with the minus 2 multiplied by b, I will get minus 2b. So at last, I will get 1 minus 2a minus b. That is my probability between 0.6 and 1.8 in terms of a and b. Okay, now b now is given that this is the fx. The x is defined from 0 to 3. For other x values, it will be 0, means undefined. Now show that the k is 10 over 81. So we know that when you integrate 0 to 3, fx dx, it is 1. Okay, that is the properties of the PDF, probability density function. So now since your k is constant, I will just take it out, factorize the constant, then integrate the rest. So here is going to be x squared multiplied with 3 minus x squared dx, and this whole integration is 1. So now I will do expansion first. So this squared, okay, the quadratic expansion, you can just refer to this formula. So now remain the x squared. So square of 3 is 9, then minus 6x plus square of minus x, it will be plus x squared. Dx equals to 1. And next step is going to be the expansion. So expand first before I integrate. So this is going to be k integrate 0 to 3, 9x squared minus 6x cubed plus x degree 4 dx equals to 1. Okay, so when you need to integrate, remember, we always add 1 degree to the existing degree, then divide by a new degree, and if we with limits, alright, integral with limits, then no need to plus c, otherwise we have to plus c. So in this case, we do not plus c, just apply the formula. I'll get 9, x squared becomes x cubed over 3, minus 6, the x degree 3 becomes x degree 4 over 4, the x degree 4 becomes x degree 5 over 5, 0 to 3, then equals to 1. Okay, so from here, you can simplify first. The 9 over 3 is going to be 3. So here I will change to 3. This is 2 and here numerator is 3. Then I will just direct replace the x by 3 first. So I will get 3 bracket 3 cubed minus 3 over 2, 3 degree 4 plus 3 degree 5 over 5. Then minus when the x goes to 0. So everything will be 0. So here I will get 81 minus 243 over 2 plus 243 over 5, then equals to 1. Okay, so the total of the values inside the brackets will be 81 over 10. Then multiply with k and it will be 1. So from here my k is going to be 10 over 81. So this is how I solve this question. Now, part 2, find the variance. So for variance, you need to count the expected value first, ex. Okay, so now I will refer back to this fx and replace the k by 10 over 81. So it will be basically, okay, for your information, ex is x fx dx. This is the definition. So now I will write 10 over 81 integrate 0 to 3. Okay, remember x multiplied by fx. So here, this is going to be your fx. Look at here. This is your fx. Alright, this is your fx. This is your fx. Which means now, all these x, I just need to multiply by x. That will be my x fx already. So I will just direct refer to this expansion and just multiply each of the term by x. So it will be 9x cubed minus 6x4 plus x degree 5 dx. Okay, then here is going to be 10 over 81. Then now do integration. I'll get 9x degree 4 over 4 minus 6x degree 5 over 5 plus x degree 6 over 6. Then from 0 to 3. Then now, just need to replace the x values. So I will get 10 over 81, then 9 over 4 to the times 3 power 4 minus 6 over 5 times 3 power 5 plus 1 over 6 times 3 power 6, then minus 0. Okay, then here you will be getting 3 over 2. That is your EX. Now, after you have found the EX, the next one is to get the EX squared. So my EX squared. So for EX squared, the difference is the x over here, right? Just multiply by another x because this is degree 2. So the definition is integrate x squared fx dx from 0 to 3. Okay, so I will just multiply all the terms in this step with x. So it will be 10 over 81, integrate 0 to 3. Then 9x degree 4 minus 6x degree 5 plus x degree 6 dx. Okay, so now do integration. It will be 10 over 81, 9x degree 5 over 5 minus 6x degree 6 over 6 plus x degree 7 over 7. The limits from 0 to 3. Then from here, second term, the 6 and 1 over 6 can be cancelled off. And then now I will just replace my x values. So it will be 9 over 5, 3 power 5 minus 3 to the power 6 plus 1 over 7 times 3 power 7. Then minus, when the x equals to 0, all the terms will be 0. Then from here, I will be getting 18 over 18 over 7. Okay, so at last, my variance x is going to be EX squared minus square of the EX. Then now just replace the values. So EX squared is 18 over 7. The EX is going to be 3 over 2. Then you square it and you will be getting 9 over 28. So that is the variance. Okay, now number 4. The number of accidents per 3-month period on a certain route has distribution PO lambda. PO is actually the Poisson. In the past, the value of lambda has been 5.7. Following some changes to the route, the council carries out a hypothesis test to determine whether the value has decreased. Okay, if there are fewer than 3 accidents in the randomly chosen 3-month period, same period here, 3 months, the council will conclude that the value of lambda has decreased. Now, A, find the probability of type 1 error. Okay, so basically, your x is Poisson 5.7. Okay, it's mentioned that your h0 lambda is 5.7. Now, the testing is regarding the lambda has decreased. That means the lambda less than 5.7. So from here, probability of type 1 error. Type 1 error is basically P reject H0. Okay, probability of rejecting H0 given that H0 is true. Alright, so from here it's mentioned that if let's say less than 3 accidents, then we will conclude that the lambda has decreased. Alright, so when reject H0 means that we will conclude that the lambda less than 5.7 means that has decreased. Or in other words, this means the number of accidents is less than 3 because it's already mentioned here, right? So every time when it is reject H0, then you have to check here. Alright, so in this question, it will be reject H0 when the x is less than 3. Okay, given that H0 is true, so when H0 is true, our Poisson is going to be PO 5.7. So x is PO, Poisson distributed with mean 5.7. Alright, so when px less than 3 means that px equals to 0 or 1 or 2. Okay, and now again this is Poisson distribution. The formula already shown in the previous question is basically px equals to x, you will get e minus lambda times lambda power x over x factorial. Okay, that is the formula to count the probability of Poisson distribution. So now I will get the E minus 5.7. Okay, I will factorize this out. Then when x goes to 0, it will be 1. Then plus when px goes to 1, after you factorize the exponential, you still have 5.7 degree 1. Then the next time is going to be 5.7 squared over 2 factorial. So from here, I will be getting 0.0768. So that's the type 1 error probability. Okay, B, find the probability of type 2 error if the mean number of accidents per 3-month period is actually 0.9. So now your lambda 1 is 0.9. Okay, so now P, type 2 error. So the definition for type 2 error is accept H0, given that H0 is false. So from previous calculation, we know that when it is reject H0, here, reject H0, it will be x less than 3. So when accept H0 means that it will be 3 onwards for the x values. So here I will write p x at least 3. Okay, H0 is false. So if H0 is false means that we will conclude that the lambda is basically less than 5.7. That's why you are given the actual value is 0.9. So now I will write x is basically Poisson distributed with mean 0.9 because the H0 is false. Okay, so now when px at least 3, so it will be 3, 4, 5, 6 until infinity. Therefore, I will use 1 minus all previous values. So it will be 0 until 2. So now again use the same formula. It will be E negative 0.9. Alright, then the first one is going to be 1. Second is 0.9. Third is 0.9 degree 2 over 2 factorial. So now this is going to be 0.0629. So that's the solution for part B. Okay, question number 5. The masses in grams of large and small packets of Maxwell cereal have the independent distribution of these two. Okay, both are normally distributed. Now A, find the probability that a randomly chosen large packet has a mass that is more than double the mass of a randomly chosen small packet. So now I will just define large packet as the first one, okay, because it's mentioned large and small respectively. So the first one is going to be large. So it will be 410.0, 3.6 squared. And then the small one, I let it be S. So S is normally distributed 206.0. And then for the variance is 3.2 squared. Now, it's mentioned here, the large, right, probability of large is more than double of the small packet. So from here, I will change to PL minus 2S greater than 0. So now I have to find what is my E, expected value for L minus 2S. So this is the expected value for L, this is expected value of S. So it will be EL minus 2ES. So this is going to be 410.0 minus 2 of 206.0. So here is going to be minus 2. Okay, and then for variance, this is going to be variance L plus, now this 2 means double. Okay, therefore it is 2 squared variance S. So now I will get 3.6 squared plus 2 squared is 4. So variance S is 3.7 squared. So at last you will be getting 67.72. Okay, so from here I will get the distribution. So L minus 2S is basically normally distributed. The mean is minus 2. And then the variance is 67.72. Now, I will standardize this L minus 2S. So it will be Z more than 0 minus 2 based on this mean over square root of 67.72. Okay, Then from here, you will be getting probability of z more than 0.243. Then when more than 0.243, when you refer to the normal graph, okay, here is 0.243. The region is over. Right hand side is towards the right hand side. Therefore, it will be 1 minus the previous probabilities. So it will be 1 minus b, z less than 0.243. And get the probability from the table, then you will get 0.5960. Once you have minus, the answer correct to 3 significant figures is going to be 0.404. Okay, so now the packets are placed in boxes. The boxes are identical in appearance. 60% of boxes containing exactly 10 randomly chosen large packets. 40% of the boxes contain exactly 20 randomly chosen small packets. Right. B. Find the probability that a randomly chosen box contains packets with total mass of more than 4080 grams. Alright, so now from here, we need to get what is the total mass. Alright, so from here, I know that 60% will have exactly 10 large packets. So expected 10 large. Okay, just now, refer back to the previous. Your large is 410. So now I need to get 10 large. What is the mean? Alright. So now 10 large, the expected value of 10 large packets, it will be 10 expected L, which is 10 times 410. Then I will get 4100. Then for the variance of 10 large, it will be, because now the 10 is the 10 packets, right? It's not the multiple. It's not the multiple. Okay, therefore we will just write the 10 here, no squared, because that is the total, right? It's not the multiple. So here it will be 10 times the variance of L is 3.6 squared. Then I will get 129.6. Alright, so from here I know that my 10L is N 4100 and 129.6. That's the mean and variance. Now, then you have 20 small packets. So I have to redo all this. Alright. So for the small packets, E20S is going to be 20 ES. So now I'm getting 20 times expected S. So the expected S is 206. The variance is 3.7 squared. So here multiply by 206. And then you will get 4120. So for the variance 20S, again this 20 is the total. I will get 20 variance S is going to be 20 times 3.7 squared. This is going to be 273.8. So from here I will get the distribution for 20S, which is with 4120 and 273.8. Okay, these two are the distributions. Now, we need to get the probabilities. Okay, so now it's mentioned that, Now, it's mentioned that the total mass of more than 4080 grams. Okay, so from here, I need to count the probabilities that either 10L or 20S is greater than that probability first. Then only I consider this 40% and 60%. So now I need to count P10L is greater than 4080. Means that the total mass of the large packets. Alright. So now, since I have found the distribution, I have formed the distribution here. So standardize it using the corresponding distribution. Then this is going to be P, Z more than negative 1.757. So more than a negative value. Then I have to sketch a graph. Let's say this is a negative. negative 1.757, the region is towards the right side because it's more than. So since the region, the critical line is negative, then I have to refract. Okay, so it's going to be 1.757, and then the region is towards the left hand side now. So this region, which is towards the left hand side, is available in the normal table. Then I will just read this probability from the table, and you will be getting 0.9605. Okay, now it could be the total mass here, right, more than greater than that value comes from the 20s. So now I will count P20s greater than 4080. So again, I standardize it. It will be 4080 minus, now my new distribution with mean 4120. The variance is 273.8. So now you have to divide by the square root, which is our standard deviation. Then you will get PZ more than negative 2.417. So when more than negative 2.417, again, graph. So the value is on the left hand side because it's negative. And again, the region is towards right side. Now use the same concept as just now. We reflect it. The purpose we reflect it is to get the positive critical value. So now again, the region now is PZ less than 2.417. Okay, and this probability can be found using table. So the probability is going to be 0.9921. That means, okay, for the 10 large packets to be with the total mass of greater than 4080, it will be with 0.9605 probability. Okay, so it's mentioned that 0.6, right? See here, 60%, right? 60% with 10, exactly 10 large packets. So it means that 0.6 of the boxes, then you will contain 10 large packets. Okay, and then 0.4 of the boxes will be 20 small packets. We'll have 20 small packets. All right, so now the question is asking for what is the probability that a randomly chosen box. So therefore, I have to consider these two cases. So now my probability is going to be 60%, 0.6 of the 10 large packets greater than that mass, which means the 10 large packets greater than the mass is 0.9605. Okay, all is plus, then 40%, therefore 0.4, and the second probability is going to be 0.9921. So at last, you will get 0.973. I use a plus here because of a box, right? A box is chosen. So you look at the question over here, a randomly chosen box, right? So the box can be containing the 10 large packets or 20 small packets. That's why all means plus. Okay, so that's the explanation for this question. Now, question number 6. Last year, the mean time taken by students at a school to complete a certain task was 25 minutes. Akash believes that the mean time taken by this year's students was less than 25 minutes. In order to test this belief, he takes a large random sample of this year's students, and he notes the time taken by each student. He carries out a test at 2.5% significant level for the population mean time mu minutes. And this is the null hypothesis, right? Mu equals to 25. Now, A, give a reason why Akash should use a one-tailed test. Okay, so his belief is the mean time taken was less than 25. Okay, so therefore, he is expecting a decrease in mu. So when decrease in mu, it will be one-tailed test. All right, so the reason is Akash is expecting a decrease. So when increase expecting an increase, it is also one tilde-test. Alright, for two tilde-tests, it will be a change. So this is the reason. Now Akash finds that the value of the test statistics is z equals to negative 2.02. Explain what conclusion he should draw. Okay, so now for this, I have to write down the H0 first. Your mu equals to 25 is mentioned in the question, and he's expecting a decrease, so less than 25 for the mu. And now it's mentioned that it is 2.5% significant level, means that your alpha is 0.025. Now, when I refer to the graph, okay, because of the less than 25 in your H0, H1, that means this is one tilde-test and it is on the left hand side. This is going to be 0.025, and now I flip it, okay, because I need to find what is this line. So when I flip, this is 0.025, and then I'm going to use the, let me see the question first. Okay, it's already mentioned here, the z. That is the normal test, okay, the z-test, which means now for z-test, I need to know what is this total region, the green arrow. Obviously, it's 1 minus 0.025, which means it's 0.975. So when you refer to the table, okay, so when 0.975 is 1.96, but then I'm not going to label the green line. I'm going to label the blue line because that is our actual value. So just times negative to the value that you have obtained from the table. So which means I will write reject H0 if the z is less than negative 1.96. Okay, that is our critical criteria. So now given z is negative 2.02. So it's given over here. So now if negative 2.02, that means it is inside the region. So whenever inside the region, right, based on this critical the rejection criteria, we have to reject H0. Okay, so that is our decision. So I will write reject H0. Okay, or probably you can just write down given this, so which means it's less than negative 1.96. So we reject H0. Okay, so when reject H0 means that we support this. Okay, so now go back to the question. Right, Akash believes that the mean time taken by the students was less than 25. So that is there is sufficient evidence to conclude that. Right, so there is sufficient evidence at alpha equals to 0.05 to conclude that the mean time taken by this year's students was less than 25 minutes. Okay, so that is the conclusion. Alright, so now in a different one-tier hypothesis test, the z was found to be 2.14. So given that this value would lead to a rejection of H0 or null hypothesis as alpha percent significant level, find the sets of possible values of alpha. Okay, so now let's say this is a graph. Okay, your z value is positive. So here is 0, here is 2.14. And then this is going to be alpha percentage. Alright, so from here I will write P z less than 2.14. I'm referring to the table from the normal table. This probability is going to be 0.9838. So which means here is 0.9838. So obviously when it is more than 2.14, it is 1 minus this probability. So P z more than 2.14 is going to be 1 minus 0.9838. So it's going to be 0.0162. And now we need to find this alpha. Okay, this alpha percentage, just convert this decimal into percentage. So the alpha percentage is going to be 0.0162 times 100%. Okay, then you'll be getting 1.62%. Therefore, our alpha must be at least 1.62. Okay, then you will reject the H naught. Okay, now the population mean time taken by students at another school to complete a test last year was m minutes. Sorin carries out one tailed test to determine whether the population mean this year is less than m. Okay, using a random sample of 100 students, he assumed that the population standard deviation is 3.9 is given. The sample mean is given. This is your x bar, 24.8 minutes, and this result just leads to rejection of null hypothesis. So means that when x bar equals to 24.8, the H naught is rejected at 5% significant level. So what is your m? Alright, so from here I will write down the steps first. H naught mu, okay, because we are testing the mean. So mu equals to m. The H1, the mu is less than m. Less than because he believes that it will be, he wants to determine whether it's less than m or not. Then now alpha is 5%, 0.05. Okay, then now I will draw the graph, sketch a graph first. Since this is less than, that means the region is on the left hand side and this is going to be 0.05. And then now I need to flip it. Okay, so when I flip, this is going to be 0.05 and all previous property is going to be 0.95. Now, when you refer to table, when it is 0.95 probability, the critical value is going to be 1.645. Therefore, the actual value for this blue line is negative 1.645. So I will write reject H naught if the Z is less than negative 1.645. Okay, and now it's mentioned that it is reject H naught. Okay, so now your Z value, I count the value first, then I will compare. So it will be x bar minus mu over s over square root n. This is the formula for the Z. And now, okay, in the question you are given the standard deviation 3.9, m is 100, x bar is 24.8, the mu is m. Okay, and we know that the result is reject H naught. See, this result leads to rejection of H naught. So now, reject H naught. This is the result. So when reject H naught means that it will be 1.645, minimum 1.645, right? So negative 1.645 equals to x bar is given, which is 24.8 over here. So I will write 24.8. The mu is the mu at the H naught. So when you refer to the H naught, the mu is m. So here, m minus m over standard deviation is given in the question. Here, population standard deviation. Okay, it is population, so it means that this is going to be sigma, not s, because the s is sample standard deviation. So now your sigma is going to be 3.9, then the n is 100. So I will write 3.9 divided by square root 100. Okay, so from here, this whole term I move up. So I will get negative 1.645 times 3.9 over square root 100 is basically 10. That equals to 24.8 minus m. Then now I can get my m by moving the negative m to the right side, and then the rest of the terms will be moved to the right hand side. Okay, just swap. So from here, my m is going to be 24.8 plus 1.645 times 3.9 divided by 10. Then I will be getting 25.4. So that is my m value. Okay. Alright, so I have completed the whole paper. Thanks for watching. Please subscribe to this channel and introduce it to your and recommend it to your friends. So, and stay tuned for more upcoming videos. All right, thank you. Bye.